1.6 is going to be solving linear inequalities. Our inequalities, again, means that we have our symbols less than, equal to, greater than, and greater than equal to. Not equal signs, because otherwise it would be solving linear equations, which we did back in section 1.3. So at this point we're at inequalities, where we will be using the symbols as opposed to an equal sign. However, the solving process doesn't change. We solve it the same as we do an equal sign. We distribute if we can. If there's grouping symbols, we get rid of them. We get rid of fractions the same way we do with our equal sign. We combine like terms, whether those like terms are on the same side or whether they're on variables on two sides. We combine the like terms. We add and subtract the constant over to the other side so that we can get the variable by itself. And then we multiply or divide the coefficient out. Now, all of those are the exact same rules that we do as the equal sign. But as you notice on the last step, there's these big old stars. Same thing I want in your notes. Star this, highlight it, because we tend to forget it. And we make this silly little mistake. Because when it comes to inequalities, this is the only exception to the rule. When you add and subtract, you're fine. There's no changes. But when you multiply and divide, you have to be careful, because if you do it by a negative, again, if you multiply or divide by a negative, you must change the direction of the inequality symbol. Less than becomes greater than. Greater equal becomes less equal. If you multiply or divide by a negative, make sure you switch your symbol. When we graph these, and you will be required to graph them, because when we talk about x is less than 2, there's more than one solution to that. It's not just 1 is less than 2. There's an infinite amount of numbers that are less than your solution. So we need to make a number line. And we talked about this back in section 1.1. When we make a number line, we have to make it properly. That means it has arrows, it has a label, it has an origin. Then you can put your corresponding point on and go from there. The number that you use, the number that's in your answer on the number line. You don't need to tick it off. You don't need to go 1, 2, 3, 4 and make little tick marks, 1, 2, 3 going across, -1, -2, -3 going across. Just use the number you get in your answer. If you get -4, there you go. There's -4. I don't need to see that you can count 3, 2, 1, or whatever. Okay? So just use the number that you get in your answer. Then decide, is that answer, is it an open circle or a closed circle? And that's based on the symbol in the problem. Now the symbol, if it is less or greater, means it's an open circle. The answer is not included. If it's less equal or greater equal, the circle is closed. That means it is included in your total solution. Just kind of a common sense, if you have less than $5 in your pocket, that means you don't have $5. So 5 is not included. That's why it would be an open circle. So you need to make sure you know which symbol you have to know which circle that it gets, open or closed. Then we need to shade all of the other possible solutions. And you shade in the direction of the true solutions. Now, probably back previously you were told to shade in the direction of the arrow. We don't do that because before the variable always came first. The variable doesn't always come first anymore. So we don't use that philosophy. You need to be able to read an inequality and shade in the direction of all true solutions. Okay, and we're going to look at a couple of examples. Seven x plus 9 greater than or equal 10x minus 12. All right, we're going to kind of just ignore the greater than equal at the moment, and we're just going to solve this. Put our letters together by moving the 7x. So we get 3x minus 12. And then move our number over. So we're going to get 21 is 3x. And then we get to divide, so x and 7. Now when I read this, it says 7 is greater than or equal to x. I need to be able to read this properly, which means I need to read from the letter. Whether the letter is first or whether the letter is second doesn't really matter. I need to be able to read backwards, so to speak, and in this case that's what that would be. But this says x less and equal to 7. Because when I read from the x, I'm reading backwards, and that says x less because it read 7 greater. So if I read backwards, it's got to be the other symbol. It's got to be the other way. So when I graph this, here's the solving part of it. So when you're asked to graph this, you make a number line that has a label on it, and the label is going to be whatever the letter of the problem is. Here's my origin. Here's my number in the problem, 7. Now I need to decide open or closed circle. The open or closed circle is based on the notes up here that says if it is a less equal is closed. That means I'm including 7 in my solution. And then less, everything less of 7, in this case, is to the left. Now, you can feel free to color in your line if you like. Make sure it's very clear that that goes on and that it goes on forever, meaning an arrow. Or you're going to see me frequently just draw an arrow in the direction that it goes. I don't normally color in a number line, but if you choose to, that's fine. Just make sure that it's very clear that that's the direction that it goes and that it goes on forever, which does mean it needs to have some kind of a arrow on it. If I give you a picture, let's call it x, 0, 3, and I'm going to say, looks like this. Can you write the equation? So could you tell me the solution if I gave you the picture? Just like if I gave you the solution, could you give me the picture? Can we now go backwards? Hopefully we can. Always start with a letter. Anytime we can write something, we want to start with our letter. So there's our x. The fact that it's an open circle tells me that it's either going to be less or greater. It's not going to be equal to. And the fact that I am shaded to the right, or I am every number bigger than 3, that means greater, and then the 3. So hopefully now you can go back and forth between the two of them from solving to a picture, from a picture back to what the solution should have been. All right, those are single inequalities. Now we're going to have what's called compound inequalities. A compound inequality means it has two inequalities that are joined. They're joined together by symbols and also the word and or. Compound inequality. Two inequalities. They use the word and or. And they also use symbols. So here's a couple of examples. -2 less than or equal to x less than 1. And x less than -1 or x is greater than or equal to 2. Now, the or is obvious. You can see that. The or is or. The and is not so obvious because we don't generally write the word and in a compound inequality. When you see that x is between two things, that implies the word and. X is greater than or equal to -2, and x is less than 1. So we read this in both directions, which gives me the word and. If you're or, there's no other option. You're this or you're that. So those are separated out. When we graph these, they are specific graphs. An and will always shade in between those 2 points. Let me say that again. An and will always shade in between those 2 points. An or will always go in opposite directions. You're either one way or the other. You cannot be both. But when you're an and, you are between two places. All right, so when we want to solve a compound inequality, we want to solve an and problem or an or problem, we make our two inequalities. Because if you have an and and an or, that means you have two situations going on. We solve them normal and graph. So what is that actually going to look like? Let's take let's look at a couple of examples. All right, let's start with an and problem. -9 less than t plus 4 less than or equal to 10. Now I know this is an and problem because I have something in the middle of two symbols. When I do these and problems, I can only work from one edge through one symbol. All right, so let me show you what that means. -9 is one edge through one symbol. So -9 is less than t plus 4. Now if I go from the other edge through one symbol, I get t plus 4 is less than or equal to 10. That middle goes in both directions. Whenever you have an and, the middle goes to both equations. All right, now it says solve normal. So that means we're going to subtract the 4, and with an and, it has to come back together. So this is going to be negative 13 less than t less than or equal to 6. You're going to put and back together. One thing that will always, always, always be true with an and problem. Again, this is kind of a highlight here. With an and problem, the numbers will always be least, greatest, with the variable in between. Always. And the symbols are always less or less equal. You will not see an and problem, anyways, not one that's written correctly, in any other format than this format. It will always be smallest number, variable, greatest number. And these symbols will always, always, always be less or less equal. But they are not greater symbols. When you write a proper and, you will never use greater symbols. All right, now we're going to graph this. Here's my number line with arrows. There's my label. It's T because that's the letter it gave me. Here's my origin, 0. Here's negative 13, and here is 6. I only need to write the numbers that came in my solution. I do not need to write the tick marks. All right, 13 has an open circle because it is less. 6 has a closed circle because it is less equal. And then I shade between because it's going to be an and. I'm greater than negative 13, so greater than negative 13. And I am less than 6. So again, I don't ever really shade a number line. I use these arrows, but you can see these arrows overlap in the middle. This will always be true for an and situation. If it doesn't come out that way for an and situation, check your math. Did you change symbols when you divided by a negative? Did you add and subtract correctly? You know, something to that effect. But otherwise, it should always come out this way. So for an or, how about 6 plus 9 is greater than 1? Or 3x minus 8 is greater than 13. Let's see. Let's make that a negative 1. Okay, so here we're going to get 6x is greater than negative 10. X is greater than negative 10 6, which is actually negative 5/4. Because anytime we have fractions, we want to make sure that we reduce them. All right, here we're going to get 3x is greater than 21, so x is greater than 7. Every single time you have an or problem, you better have an or in your answer. So x is greater than negative 5/4, or x is greater than 7. When I graph this, I got a number line, I got a variable, 0, there's negative 5/4, and there's 7. Just need to use the numbers that I have in my problem. On negative 5/4, it is open. And I am greater and x greater than 7. Oh, I don't like that. So the way that we fix that, let's go back and fix that. We're going to change that to a less than symbol. That'll change that to a less than symbol. That'll change that to a less than. And that will change that going to the other direction. Now we have a true or going in opposite directions. And that's what we want. When they go in the same directions, that's something different, and we're not working on that right now. So go back, make that adjustment, sorry. Make that a less, make it a less, make it a less. Therefore, now it's going less. This is going greater. And that's my final solution. All right, that will hopefully get us started with our assignment that we need to get in class. If you have questions, make sure you come with them. Go back over this, study your notes. Slow it down, pause it, rewind it, whatever you need to do so that you have all the information. Sorry about that last problem, but go back and make sure to change that symbol to a less than. And I'll see you tomorrow in class.